Hello everyone. This little video scenario is going to go over the count widget. So the count widget uses different methods to count different clusters of pixels, we call them. And you can adjust all of these different settings down here in order to count all the clusters that you desire. But we call them blobs within Clarity, so just for little lingo for you. Alright, so I started off, I'm just going to click the count widget icon. Right now I have a bunch of canned images from previous jobs. Right here is just a picture that we had made with a set background value, and as you can see, a bunch of different squares. And so I'm going to go back to the blob count. What we want to do first is adjust our region of interest, which is this red square here. So you just click and drag from these red circles over here to get the area that you desire. We have three different types of blob counting. So first you count the actual blobs. You can count the boundary of the blobs, which if you can zoom in here, you can see some different colored highlighted edges up there. And then another option we have is the boundary matching, and you can train the program to look for a certain reference boundary. But we're not going to do that right away. So we'll start off focusing on this bottom area of the light blobs. So within Clarity, you can choose to either look for dark blobs or light blobs. We're going to switch over to the light blobs. And what we want to do is go back to blob counting. And as you can see, all 12 of these squares in our region of interest have been counted. Now let's say that we want to only count the medium-sized box. So how we do that is adjust our maximum area and our minimum area. And that is strictly just the number of pixels in each cluster. So our max area, we just need to reduce to get rid of the large ones, and that seems to be good enough. And then the minimum area, we need to increase to get rid of the smaller areas here. And voila, we have just the middle boxes, and as you can see over here, the blob count is 4. Another thing to point out about here is you might have noticed that this started out as red and then turned to green. And that is because of this pass criteria section over here. So if you have a required number of items that you need to count, if you need them to be less than 10, which is what we have here, this will fail unless it is within that range. So that's what that is. So you can adjust this if you only want 4 blobs. You can have a minimum of 4 and a maximum of 4, and then if you have anything outside of that, it'll turn back to red. So let's just go back down a little bit to get those out. Alright, another thing that we want to touch on today is let's work on this threshold area. So this threshold area just talks about the brightness of the pixels. And right now it says the threshold is 160. If you hover over any area in your image, if you look down in this section over here, it'll give you the RGB values of that pixel. So the background is 125, this white area is 255, which is the brightest you can get, and then the black box is all zeros. So let's try a fixed option here. And let's say that we only want to count anything that's exactly white. So all we have to do here is just increase our threshold all the way to the top, and as you can see, only the white blobs were counted for. And you could do that in the reverse as well. Let's go back to adaptive here. Let's give the black boxes a go. So as you can see, nothing lit up because our blob polarity is still set to look for the light clusters instead of the dark clusters. And as you can see, the threshold here is set to 40. So the background of this is 125. This slightly dark gray is 40, so it's not counted. And the dark blob is 0. So we can go to fixed. And if we lower our threshold, bang, bang, everything's counted. And as you can see, only the medium boxes are selected because our max and min area are still the same as before. Let's try another way to count using the boundary counting. We got to switch back to light blobs, and we're going to go back to adaptive, which is auto threshold. Let's do boundary counting. Excuse me. So in boundary counting, what you can do is the program will look for a closed boundary, and then we'll count that as a blob. So as you can see, I'm sorry about that, this whole box is outlined in light blue, and so it's counting that whole bounded area as a blob. As you can see, these smaller blobs aren't counted, but that's because our minimum length is set to 100. So let's just lower that to 5, and voila, they're all in there. And as you can see, the ROI is highlighted red again because there's a max number of blobs is 10, and right now it's counting 12. Excuse me. Let's try another thing where we do boundary matching. Let's train in on one of these huge ones. As you can see, it gets highlighted in blue, so that way you know it's an acceptable boundary. And we're going to accept that. And let's scroll out a little bit. And let's adjust our region of interest. And as you can see, we are getting these 8 blobs here. And I just changed it to 8, so it was a pass. But over here you can see the closed boundary length is 397. So let's say that you only wanted the boxes that were the big boxes. So you can adjust your minimum length to be just under the 397, and it'll nix out all the other ones. So it matches what you need. Let's go back to blob counting. And what we're going to do here is show you the allow boundary option. So let's get this max area back up and the min area down. Alright, so if you can see here, right now the program is only counting blobs that are completely enclosed in the region of interest. Let's say that we want any blob that could be in the area. So we click allow boundary blobs, and what happens is the program recognizes any cluster of blob that doesn't have a full boundary on it within the ROI. And that's what's happening here. Alright, so let's do some more realistic blobbing rather than these beautiful perfect squares. So we'll just get rid of that picture. And we'll go to picture number 1, which I don't know if you can see is some M&Ms and some chocolate wafers. Alright, so we have to adjust our region of interest here to fit. This section is the only section we're interested in. And if you can see, there's these there's counting 18 blobs right now, and that is just these smaller clusters of pixels in here because our minimum area is set to 5. So let's do for this first blob count function, let's only count the larger wafers. So what we have to do here, first things first, we're still set to only look for the light blobs, and we want the dark blobs because they're darker than the background. Alright, so let's up this minimum area, and so we don't want any of these smaller areas. We only want specifically this sized wafer. And in our pass criteria, let's say we want at least 4 wafers, and we're going to put our maximum to say 15, because there's no such thing as too many chocolate wafers. Okay, so that one looks good to me. Let's do another count function, count widget per se. I'm sorry, let's go back to this one real quick. And I just want to edit this so I know what it means. And this is going to be number of wafers. Okay. And back to a new blob count. So we just have to adjust this region of interest again. And there we go. Alright, so this one we're only going to count the M&Ms. So same automatic threshold as before. And we need to up this maximum area to include all of that. And we want to increase the minimum area so it's just under the size of our M&Ms. And we want our max area just over the size. And as you can see, this upper M&M isn't being counted because it's on the border. So let's just adjust this a little bit. There we go. We were getting this dark edge that we don't want. Alright, so now we have 1, 2, 3, 4, 5 M&Ms. So there is that. And let's adjust this name so it is a number of M&Ms. Okay. And we're going to do one more, which is just going to count all chocolates. And once again, we'll have to adjust the region of interest. We're going to do here is just, adjust the max area to include the wafers and the minimum area to include just under the M&Ms. So 4 wafers, 5 M&Ms, 9 total chocolates. Alright, so let's do a quick output here. We're going to add text. The first thing we're going to look at is the number of wafers. And within this drop down, we're going to do the blob count, which is going to output how many blobs it literally counted. We're going to add another text output, space first, number of M&Ms. And within same thing, blob count, add output, and then add another text. Scroll over to see that. Space, is there enough chocolates? Which is the main question in life. Alright, so number of chocolates. And right here, we're going to do the result. So let me just adjust a quick thing so that actually makes sense. So let's say the reason we're doing this is we want to make sure that we have enough chocolates in life. So the max number of blobs, we'll say, is 100. And then the minimum number of blobs, let's say we want to have at least 9 chocolates. Let me just make sure that everything else matches this. Max number is 10. Max number is 15. Minimum of 4. Alright, so in our output result, you can see the number of wafers is 4. The number of M&Ms is 5. And then, is there enough chocolates? Yes, there is. Alright, so let's run the next image that we have. And this also passes because we have 1, 2, 3, 4, 5 wafers. And as you can see, we have allow boundary on. So this wafer is also counted. And 1, 2, 3, 4, 5, 6, 7 M&Ms. 5, 7, and that is more than the 9 chocolates, so passed. And as you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have no wafers, but we have 9 M&Ms, so there is enough chocolate. But as you can see, this is still highlighted in red, so you know. Run next. Alright, this one we have a false. So we have 5 wafers, which passes because that's more than 4. No M&Ms, but not 9 chocolates, so it fails. And then this is back to the beginning. So that covers most of the basics. All right, thank you.